One of my Patreon supporters asked the question, how do we detect that the universe's expansion is accelerating? A part of the answer to that is something we call redshift. Now, because light is a wave, when you have objects moving towards you or away from you, their wavelengths can either get compressed when moving towards you or stretched out when moving away from you. It's similar to like sirens on an ambulance. As the ambulance moves towards you, the sound waves get compressed and the pitch, the frequency increases. But as it moves away, the frequency decreases because the sound waves get stretched. With light, when you get compressed waves, it gets blue shifted, so it gets shifted this way on the spectrum. When they get stretched out, they get shifted that way to red. And that's all great because that tells us that things are moving away from us. But how do we know how far they are? For this, we use a specific type of energetic event that has a specific luminosity when it goes off. Type 1a supernova. Now, Type 1a supernova happen in binary systems where at least one of the stars is a white dwarf. When the two objects merge after spiraling towards each other, a cataclysmic event happens and a supernova goes off. A very special thing about Type 1a supernovae is that they always have the same luminosity. So we call them standard candles. And because we know how luminosity is related to distance, we can then figure out in some galaxy that we see where a Type 1a supernova just went off, how far away it is. But we also know what their spectra looks like. So we can then see by how much it is redshifted. Combining the information that we have, distance from our standard candles, Type 1a supernovae, as well as the redshift, we know that the universe is not only expanding, but its expansion is accelerating.